and every item of that array is 1, 2, 3, 4. In other words, in your computer memory, you're basically holding like a table of row 1 because it's 1D, and the table has 4 slots. The first slot has the value 1, second slot has the value 2, 3, and 4, and the table name is X. That's what basically line 1 is doing. And similarly, the line 2 is saying make another table of 1 row and 6 columns because the size is 6 here. 1, 2, 3, 4, 5, 6, and the values are 2, 3, 5, 7, 11, 13. This is what the second line is doing here, right? It's basically making a table and putting in values in those tables. Another thing you need to know is indexing and how array indexing works. Basically, always you gotta know that indexing start with 0. It's the computer science thing. It's not something I made. In real life, we start from 1, but in comp sci we start from 0. So if the first index is 0, second index is 1, third index is 2, and the fourth index is 3. Basically, it's a 1 below, like 1, you subtract from that. So this becomes 0, 1, 2, 3, 4, 5. And why do we need to know the indexes? Because in order to access each one of these items, I need to know which index do they occur. For example, if I need to know what value is this guy, I will write down y and then this bracket or this whatever that is. And the inside I put the index, and I know that this value is stored in index 4. So if I put 4 here, this will give me the 11 I need. So now that we know this kind of stuff, then we can get started. So first things first, first line says cout, which is the console output basically printed on the screen, the result of this thing. So now this part alone, y at 3 is basically what we just explained earlier, which is saying go to the y table and look at index 3. Whatever value is in there will be the output of y at 3. So what this part is saying is basically y at 3 is 7 because this guy is 7. And then, whoops, why it looks like a z. 7, and then we are doing modulus 9. And that's the value that will be printed for line A. So now what is modulus? I'm pretty sure you guys are familiar with this from midterm 1, but it's basically the remainder when we divide one number with the other number. So if you divide 7 over 9, what basically happens is 7 doesn't go any more times, so it takes 0 times, and 7 times 0 is, wait 1 second. Yeah, no, what am I doing? It should be the other way around. 9 mod 7 is 2, but 7 mod 7 is 7. The reason behind that is, why my 7 looks like a Z? I don't know. The reason behind that is when I divide 9 by 7, this goes 1 time. So we have 7, and then the remainder is 2, and that is the value here. But when I do 7 mod 9, it's basically the other way around. We divide 7 by 9, but 9 doesn't go into 7, so I do 0 times, which is 0, and the remainder is 7. And that's basically what modulus does. So what 7 mod 9 will print out is basically 7. So that means line A will be printing out the value 7. And let me write it in a different color so we know this is the answers. 7. Any questions so far? Tasnim said, can you do question number 122 of program output PDF after this question? Sure, yeah, we can do that. Yeah, Akrab already figured out multiple answers. That's great. So we'll do the next one. Let me use the black again. Next one says it kind of looks like a bit you just once you see like nested stuff, it always go from inside out. What I mean by that is it's basically saying take this value x at 1, and I know my x at 1 is basically this index, so this index is storing the value 2. That means the inside portion becomes 2. So the outside portion is saying take y at index 2. And if I look at the y table, index 2 is storing 5, so the value for this guy should be 5. I'm just going from inside out. The inside portion, x at 1 is 2, and the y at 2 is basically 5 because the index 2 at y is storing the value 5. Let me clear some stuff. This was 5. Okay, so next line is using the function, the f function that is written above, and it's using like this. So now inside the f function, if I look at it, I see that the first parameter has an ampersand sign, the second parameter does not. And which basically means that whatever is going to be passed in the first parameter, we're going to change this table. And whatever will be passed in the second parameter, we will not do anything in the table. So if I follow again, the first parameter is basically x at 0. And x at 0 is going to the x table, and the 0th index is storing the value 1. So eventually we're calling f with 1. And the second parameter is y at 0. If I look at the y table, the 0th index has the value 2 here. So we're basically calling like this. And remember, whatever change I make here, I'm gonna permanently change the value at this position in the table. So if I pass in this parameter at x equal to 1 and y equal to 2, so x becomes x plus 1. So right now my x is 1, and 1 plus 1 equal to 2. So my x becomes 2 now. And then y says y minus 1, the current y is 2. So 2 minus 1, which is 1. So my y becomes 2. And we return the value of x plus y, which is 2 plus 1, which is 3. So when this is returned from this function, this part, the part in red, is going to have the value 3 because 3 is the result of this function, which is the return type, and that will be printed out. So we were going to print out 3 here. Now the 3 here. Now the only thing that I'm not doing it is basically once we change the value of x in here, x was originally 1, right? And I change the value of x to 2, and I know that whatever change I make for the first parameter, I have to make the change in this table. So this table had the x at 0 originally, so x at 0 will be changed to a 2.
So then in line D, it'll become 2 in that case because
Exactly.
because I asked a question about the and symbol making a variable dynamic versus static. So what I mean by that is when we complete a function, as soon as the variable updates, it's going to affect the outside, not just the inside, because when something is static, it's only exclusive to the function interior.
Yeah, could be. You could be right. I'm just not familiar with the term static versus dynamic, but you might be right with the term definition. And also, Jasmeet, yes, the session will be recorded, so you can find the recordings in the Learning Commons YouTube channel. Maybe Yulong can send the YouTube channel link in the chat, and we'll try to upload it as soon as possible. Once it's uploaded, you're gonna get some sort of notification from your professor, I guess, and then you can look it up. Or the Learning Commons website also will have the link. So basically, that's how we got 3 because 3 was the output here, and we also need to make the change here because the first parameter has the ampersand sign, and that's why, let me clear things up first. That's why when we try to print the next line, which is x at 0, right now my x at 0 has the value 2, not 1 anymore. So this guy is going to print 2 for x at 0, and y at 0, it still has the value 2 because we didn't make any change because y never had an ampersand sign here. So it's going to be printed 2 and 2. Also, don't get mistaken by having like a space here, like, like doing like this, having, oh, hey, this is my x at 0, this is my y at 0, and we have a space in between. There is no space in the code. If you look at this line, It's like x at 0 followed by y at 0. In other words, it's not going to be printed 2 space 2, it's going to be printed 22, like that. Not sure if it's too small or not, but just let me know if it's too small to see. So once that's cleared, then we go to the next line, which is basically saying this is like a nested function, or they are using nested function in a way. So basically, every time you see something nested, you go inside out. The inside portion is basically this portion, and that the result of that is going to be second parameter of this outside function. So let's try the inside function first. So what we do here is f passing x at 1, and my x at 1 is the value 2. So I'm going to be passing 2 here, and y at 1 is the value 3 here, because the y table on index 1 has the value 3. So I'm going to be passing 3 here. And remember, the whatever change I make on the first parameter, I'm going to be making the change on the table too. So what we do in the code is basically adding 1 plus 1 to the x. So x becomes 2 plus 1, which is 3, and y becomes y minus 1. Actually, once you make the first line, you should already update the second line, because sometimes in your code, it might be the case that after I make the change here, let me think. Not really, not really. You can do it later, like the way we did it on this part. I made the change after we finished the function call. You can do it later, or you can do it right away. Like once I made the change from 2 to 3, I'll literally make the change at x at 1, which is this 2, and make the change from 2 to 3, because I just calculated the next, the plus 1 thing. But you can do it at the end, as I said before. The next parameter says y becomes y minus 1. So y was 3. So 3 minus 1, which is 2. And the result is 3 plus 2, which is, 3 plus 2, which is 5. So this part, the part I'm trying to point here, has the output 5. And I also made the change on the table, so we are all good to go so far. So now all I'm doing here is basically calling f with y at 2, comma 5. And that's my outside function, because the inside function has the result 5. So I put the result 5 here, and the y at 2, it was whatever that was originally. We just kept it as it is. So again, y at 2 has the value 5 here, because in the y table, index 2 has value 5. So basically, we're calling f function with 5 and 5. And if we do the f function one more time, it will have the value 5 and the value 5. So x will be x plus 1, which is 5 plus 1, which is 6. And y will be y minus 1, which is 5 minus 1, which is 4. And the result is x plus y. So basically 6 plus 4, which is 10. And the result here will be 10. Also, this is the last line of code, so it's okay if you don't want to make the change in the table, but just for understanding, we should also make the change here, because this parameter y at 2, the first one, had the ampersand sign. So y at 2 is this guy, and this guy I'm going to change it to a 6, because x was changed to a 6. It doesn't matter anymore, because there's nothing more to do after this last line, but just for understanding, you should make the change on your own. But yeah, that's the output or result for this question. Any questions so far, or anything you didn't quite catch it? If not, we'll be moving on to the next question. I'll give you a couple more seconds. Okay, Tasneem, I know you requested question number 122 for the program output questions, but I just want to make sure I cover every topic of the midterm before doing multiple questions per topic. So is it okay with you if I do the question number 122 at the end, after I cover recursion and function and everything else? because the revision is only 2 hours long, so I don't wanna. Yeah, exactly. Cool. So that's the one type of question you're gonna be seeing, which has the arrays. You need to know what arrays, how arrays work. You need to know how Raspberry value, Raspberry reference work. You need to know how modulus work and indexing and all that stuff. The next type of questions, I think people call it title lines, or sometimes I've seen people call it uh, function prototypes, I think. Function prototypes, something like that, which is basically, let me give an example first so I can make more sense out of it. Function signature. Let's do this one. Why not? Which is basically saying they will give like a main function only, and the main function will use a lot of other functions. For example, this is a function, then print is a function, then best state is a function, and you need to write the title line or the function prototype of the function. What basically that means is you don't need to write the body. Like for example, in this question, you see how this part is the body of the function, and this is the title line, and you only need to write the first line, which is basically this part, which has the return type, the function name, and multiple parameters, if there are multiple parameters, or single if they don't have multiple. So let's do one example. This one. Or if you guys have any other, let me see if anybody said any suggestions. Okay, never mind. So basically, again, we start from the main function and you go line by line downstairs, and then you do whatever it says, right? The first line basically is saying have a variable n, and the variable n has the value 5, and another array called numbers, N-U-M.
Apologies, I just have a quick
Yeah,
question. So he's essentially just asking us to instantiate the functions based on variable type. He's not asking us to actually write the algorithm itself.
no, exactly. Basically what they're asking is this part. They don't want you to write this inside portion of the body of the function. You don't need to know what this function is doing. You don't need to know what average is doing. You don't need to know what print is doing or best state is doing. All you need to know is the return type, like the int here, return type, and the parameters here. And the name is also already given in the question, right? Like we already know the names of the function, which is average here. This is the name, then this is the name, this is the name, blah, blah, blah. If
So
you just realize,
he's
yeah,
effectively giving us the answer already in this
yes,
question.
yes, it will already be given the main function, just to figure out what the types are. I just realized for this question, you don't need to write down in the table and stuff for keeping track because there's nothing to keep track of. So I'll just jump right into line A. And line A is saying, there is this function average. Let me still write in, can I write here or here? Okay, there you go. So basically, there you go. So this average function has 3 parameters. And how do I know it has 3 parameters? We see an n here, then a comma, followed by another n here, comma, followed by 14. Basically, every time you see a comma, it's that many times plus 1. That's how many parameters you're gonna need for that function. And so basically, we're gonna need 3 parameters because that's how they used here, 3 parameters. So I'll also, the names doesn't matter. I'll tell you multiple times. You can name them A, B, C. You can name them X, Y, Z. You can name them, whatever, mouse, keyboard, laptop, whatever you want. Name doesn't matter. But the type do matter. Let me just write down ABC first. The type that do matter. So you need to figure out what are the types when it was used in the question, right? So first things first, what is n? And I know n is a type of integer. That's why this one has to be an int. Similarly, second parameter is also an n, and I know n is a type integer. So second type also needs to be an int. And the third one is basically literally 14 as an integer. So this also need to be an int. Now, if it was 14.0, then that's not an int anymore. That's, I think, double or float. I'm not sure what the C++ type is for decimals. But now for this question only has three integers. N is an int, n is an int, 14 is like basically an int. So I'll have three ints as my types of the parameters, and I need to figure out the return type. Return type is basically what is where the output of this function is going to. The output of this function is going to x, right? And why is x? I know x is my double. That's why the return type of the function needs to be a double. Again, how do you figure it out? Basically, you want to check where the output of this function is going to. This output of this function is being assigned to the variable x. And what is the variable x? Variable x is literally wrote the line above, which is type double. So the output has to be a double. So the return type here is also a double. Also, I'm not sure if professor wants you to write down these curly braces, but I guess it doesn't matter for this type of questions. You can write down these empty curly braces or just not do anything with it. But any questions so far?
I'm checking the answer sheet for this one. He doesn't ask for the curly braces.
Okay, fair enough. So then don't put curly braces. Just do this thing. Again, let's move on to the next part. Let me do this. The next function is line B, which is the print function. So let's try to find out how to write the print function. So if you look at the print function, the inside the parentheses, right? Like this is the parenthesis, this is where it starts and this is where it ends. I only see one comma. That means there is two parameters, one before it and one after it. So I will need two variables inside the parentheses here. I'll do it A and B for the time being. You can name it whatever you want. And what are the types of A and B? We need to figure it out. So first of all, this first parameter is this thing. And I already know it's a string because of the quotation marks. If you say quotation marks and some characters or whatever inside, it's always a string. The inside portion can literally be numbers. It can be 1, 2, 3, 4, dot, 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 9, 10. This is still a string. Even though these are all numbers, this is still a string because there are quotation marks before and after it. It doesn't matter. Like, I don't need to know what's inside. I see quotation marks. I already know it's a string. And here, the inside portion of the quotation mark has the value this. I don't really care about the value because I don't need to know how the function works or what the function does. All I need to know is the type. And I know the type is a string because of these quotation marks. So I'll say my first parameter is of type string. This is my first parameter here. And then what's the type of the second parameter? It's x. And what is x? X is a double, right? Similarly, how we did the double here, and we're going to do the same thing here. I know my second parameter is x, and x was initialized as a double, so my type of the second parameter has to be a double. And the final thing is finding out the return type. Again, try to find out what's where the output of the function is used at. And I can see that this function, the output here is not used anything. Like there is nothing here. And that's where it's almost always a void function. I think someone asked when to know it's a void function in the chat before. And this is like a classic example. The output of this function is not used anywhere. And we are not, well, no. I'm wrong, because there is a comment here. I didn't even read the comment. So yeah, this dash is a comment, and the comment is saying print the following to the screen. So basically this line prints this part. Basically, it prints out whatever the first parameter is, which is x space equals, and then the value of x, which was, set here, right? So if there are comments saying what the function does, then you need to follow that as well. And this function follows this comment because usually the comment is written before the next line or before the actual code. So, and the comment is saying the function prints out this thing. And if it's something printing to the string, printing to the screen, it's almost always type string. And you can also verify it because how can you write this thing without type string? You can write this part with type double, but how about this thing? This has to be a string. The whole thing has to be a string. So the return type of this part is a string. String again is basically a collection of characters. X is a character. Even the space, like X is a character. Even the space here is also a character. Then E is a character, and all that stuff. So just pay attention to everything. Don't skip lines like I did. I didn't even read the comments, so I almost thought it's a void function. But if there are comments saying what the function do, or what the function does, or what the output does, then follow that. And I know the output is a string, so it has to be a type string in here. Let's move on to the next one. Again, next part is this guy, and I'm not gonna miss the comment this time. Let's write down part C. Oops, sorry. This is function name best state. And how many parameters does it take? Again, count the number of commas. If there are 1 commas, there will be 2 parameters, basically before and after. So since there are 2 parameters, the first one is states, second one is 3. I will have 2 variables inside. Again, the name doesn't matter. You can name everything same. You cannot name everything same in one question. You can use ABC here, ABC here, ABC here, but you cannot use AAA or BBB. Like duplicates aren't allowed in the same function, but you can have duplicates in different functions.
The first parameter isn't an int, it's a string
Yeah,
because
I'll change it. I'll change it. Yeah, I'm just writing down the things and I'll figure out the types. So basically, what the first type, again, what he said, the type of the first one is states, and I need to look at where this is state. A state is used here, which is an array, and I know why it's an array because it has this thing, and the values of the array are type string. So it has to be string and array. Again, everything will be given in the question. You just have to follow through and figure out what it is and where it's used and whatnot. I know this is basically initialized here, and this is where we know it's a type string and it's an array. Again, you don't need to know the size of an array for this type of question, but maybe later on you need to know the size of the array as well. And second parameter is b, and b on the main function is basically the value 3. And again, 3 is an integer, so it's an int here. If it was a 3.0, for example, or 3.1, for example, then it would be double type because it has a decimal portion. But just being 3, it has nothing, so I'll just put an int here. Again, if you have any question or something is confusing, let me see the chat. Average. Yeah, well,
I have a question actually.
yeah, go ahead.
You just said that we can use the same variable name. What was that? I did not get that concept.
Oh,
What was
basically, well, what I was trying to say is like, you see how I used ABC here and then AB here and then AB here. Like it has
Yes.
duplicates, right? And this is allowed. What is not allowed is saying something like this, AAC. Like this is not allowed. You cannot have duplicate variable names in the same function. But you can have duplicate variable names in different functions, right? Like ABC in this function is different than ABC on this function. and that is different than ABC and this function. Just if it's confusing to you, just make everything distinct. There are 26 characters in the English alphabet. You can make there will not be 26 variables in the question. Just use distinct if that's confusing to you.
I have a quick question.
Yeah.
So you notice on part C where they say best state, states, and 3, right? Where states is a reference to the string array containing NY, NJ, and CT, and 3 is basically just an integer. And you notice in the comment they say print a screen, the best is New York. So my guess here is that the output, what it's going to return is basically an output, or it's going, or it's yeah, yeah. What if best state is a void
It cannot be, let me think.
because it's printing something, it's not returning something.
Yeah, interesting.
Can you give one example of void
Yeah,
A
so
a,
that we
a
can
void's a
compare?
you guys might be right because we don't really know if it does print inside the function or not. And yes, because if it was a cout, let me think. It has to be a void because there is no cout. Yeah,
the same thing
uh,
should apply to print as
exactly.
well.
Yes, exactly. Because there's no cout. I didn't even catch that. Um, if there was a cout here, like this, and then the line above says, basically it prints this, that means the output of this has to be string because cout only takes a string. Like if you do this part has to be some kind of uh, string or whatever that is that's going to be printed into the console, right? And since there is no cout here, similarly, there is no cout on this part with the print part. So that means the printing happens inside the function. So we're not basically returning anything. Like you can think of it, like if you had to write it in actual the body of the function, it will be something like, oops, sorry, cout 8.0. So no, this is
Oh, I didn't
print.
even see that in the answer key. That's crazy. I actually just kind of figured it out. Oh, whoops.
A plus B, I think, something like that. Something like that. So basically, if you had to write the actual function, it will be something like this. But since we don't really know what it does inside, we have to kind of figure out, does it print inside? If it prints inside, I cannot have another string here. This has to be a void. And I know it does print inside because there is no cout here. Like some of the questions, if you see the practice problems, there will cout and then the angle brackets and then the function. And
Then it
in
has to
those
be a
cases,
string.
yeah, exactly. In those cases, it has to be a string. But since there is no cout, then the printing happens inside the function. So we're not basically printing anything from the main function. We're basically printing inside that print function. So this output or the result
Isn't
is
it
a void.
debatable though? Because because the issue with that is like when you use a cout, you're able to apply it to any kind of parameter or function.
Yeah, I agree. It doesn't necessarily need to be string. But yeah, I agree because you can cout an integer. Like you can do cout 9. Can you do that? Not sure. I'm not sure
Um,
yet. Uh,
isn't isn't part C gonna throw an error?
well, yeah, I haven't finished part C because this is a void function.
Yeah, but from I'm just predicting what the output could be, but like C could possibly throw an error because it's taking in an int, right?
Okay.
It's taking in an int and it's taking in an array of strings.
Mm-hmm.
Um, and it's printing out at position 0. What it could possibly be containing is a simple cout containing the best is with the string space, and then you'll be doing states and whatever B is.
Well, not necessarily. You're thinking too deeply, but not necessarily. This is basically the size. This is not the index that's being printed. Usually in 111, you don't need to think that deeply. Like, oh, hey, what if the array is empty? Then we don't even get to print the first value of that array, right? or what if
Right.
something like that, right? You don't need to worry about that as your first course in comp sci. You have to think like, oh, everything works perfectly. So if everything works perfectly, then what we should do? I guess what this function does inside, like if I had to write the body of the function, it basically prints the first value of that array.
So
It has nothing to do
it's
with this variable b. That's just the size of that array.
it's just basically like it's kind of trivial,
Yeah,
essentially.
basically. Yeah, so these are void again because there is no cout. If there was a cout, then I'm like 99% sure this will be a type string because whatever is being printed out has to be a type string to be able to be printed in the console. Again, moving on. So next part is part D. Also, I don't have the answer. Let me see the answer actually, because why am I making too many mistakes? This is question number 1001. So function signature. Yep, there you go. Okay, cool. So whoever has answer key, you can correct me if I'm doing a mistake. So now part D has this mystery function. So let's quickly write it down first.
It's a Boolean, isn't it?
Yes, it is because there is a if wrapping around. Again, someone figured it out. Basically, it's a Boolean type because once you write an if the keyword if and you put parentheses, the inside portion, like this portion, has to be type Boolean, meaning if can only take either a true value or a false value.
Oh, okay.
You can
Okay.
never have if something like 5, for example, in C++. Some languages do allow 5, or something else like Python maybe does it, but you cannot do something like this in C++. I'm like pretty sure. And since if can only take this type of true or false value, whatever is inside has to be a type Boolean. And I know the inside portion is basically the output of this function, right? So the return type, oops, sorry. The return type has to be a type Boolean. So let me write down the Boolean first. And the number of parameters, again, it's 2 because there's only one comma here. So
I
in
did not
what?
get this thing actually. Like,
Sure.
why is it not a void and why is it a Boolean?
So basically, you see how there's an if wrapping around. Like there's a if here, and the if has this opening parenthesis opening here, and it closes here. That basically means that whatever is inside has to be a true or false because the if condition in C++ only take these two values. You can make complex equation like 4 plus 3 greater than 5, all that stuff. Once you get the result of this, it's either true or false. Like it's not going to be an integer, it's not going to be a string. You have to calculate whatever is inside here, basically saying 4 plus 3 is 7 with 7 greater than 5, and the result is true. So what basically is being calculated is if true, and then do that stuff. And that true is basically what the result of that is. And this part, the box part, in our case, is the mystery function. So the mystery function has to output a true or a false value so the if statement can take it. And that's why it's a type Boolean. Does that answer your question?
Yes.
Okay, so it's type Boolean and there's two variables, and the two variables are, let me take a look. First one is numbers at 1, and if I look at numbers is type integer and it's an array, and that has to be basically numbers at 1 is the 1th index. So this is index 0, this is index 1, this is index 2, this is index 3, which is basically this value. And you can see all of those values are integers because numbers is a type integer. So the first one has to be a type int. If it was just numbers, like nothing here, then it will be an integer array. Like you'll have to do something like this here. But since it has an index, that means it's the value at that index, and the value at that index is basically the value 8. So the value 8 is an integer. Also like it's a type of integer array. So that's why the type of first parameter is an integer. Now going to the second parameter is states. States is type string. And state set 1 is basically the same deal, which is this guy, because this guy is index 0, this guy is index 1, this guy is index 2, and this box part is basically type string because state is a type string array. The second parameter has to be a type string.
So just to clarify, if it mentions a specific number, it would have to be int or string, right? Depending on the thing.
Yeah, depending on the array type.
Okay.
The first one has an array type of integer. That's why it was an int. Second one was array type of string. That was a string. Let me see if I missed any chat question. Part base wrong, we fixed it. Void print. Can print function with cout outside? You can have a cout in an int function. We just need to make sure it returns an int. Yeah. Yeah, he's right. A boolean returns a true or false when applied. Yeah. If there's a cout, it can be void. You can have a cout inside a void function. Yeah, you can. Yeah, you're right. A void doesn't return anything, so cout's gonna cause an error. Yeah, that's correct. Yep, everything is good. Also, whoever joined late, please feel free to do the attendance form. It helps us in more ways than you think. The last part I'm missing is the question, or part E, I should say. Okay. So question part E is the function is literally the name of the function is E. Interesting. So the name is basically E. Don't get confused with the type or the part E. That is the name of the function, and it's basically a nested function. So again, once you see a nested function, you always do inside out. So let's try to find out what this guy would do. And E is taking one parameter, right? Only parameter is X here, and I know X is a type double. That means the parameter type has to be a double. Now, what is the return type, right? Return type is the output of that function call, right? Let me do red again. This is the function, the insert function, and this is going to give me a result, right? This is going to give me a return type. And whatever result it gives is also the output of the outside function, or the input of the outside function. So this is the inside function, and this is the outside function. So whatever result this guy gives has to be the input of this same function, right? That means if the function E takes an input of double A, output of this guy has to be a double again, such that it can take the same X, or X was double initially. So that's why the output of E has to be double. Again, how did I figure it out? It's basically just following through inside out. I know that input is a double because X here was a double. And output has to be double because the outside function is taking the result of the inside function. And I know that they're the same function name. So the outside function has to take a double type as an input. And this input is basically the return type of this guy, or the inside function. So if this guy doesn't return double, I cannot take double here. So it has to be a double here. So that's the end of this type of questions. Basically, function title lines. Don't well, you can take your time doing all that. Just don't get confused by this void and if type of things. Usually, what every question I've seen has some kind of nested thing like this, some kind of if. If has a like it. There is a if, and the function is used inside the if. There is some kind of void, usually at least one, and something very easy like the part A, right? It doesn't need any critical thinking, I should say. Again, play around. There are like 100 of questions. You don't need to do all of those. Also, like, let's see. Any questions I missed in the chat? Can you explain why is not a void? A is not a void. So A, let me see, what is A? A is average, right? And average, the result of this function is going to X. And my X here is written as a double. So the result of this box has to be a double, so X can take that value. Does that answer your question, Dasni? Great. Okay, so let's moving on. The next type of questions we're gonna get is like writing functions, I should say. One of them will be recursion, I'm pretty sure. Let me see. Yeah, so you look at some kind of program design. I'm guessing one of them will include array, other one will include recursion. Let's do the arrays one first, as we just covered arrays like couple or more 15 or 20 minutes ago. Do you guys have any particular questions you want me to go over, or can I just pick anything random from the problem sheet? Well, print has to be a void. It cannot be an int. Well, let me think. Yeah, Zainab, now that I think about it, I know the answer sheet says void, but there is literally logically speaking, there is nothing wrong by having anything other than void here. It's basically not going to be do anything. What I mean by that is if print has an integer, right? If it was an int here, I don't really need to know what print does inside because it's not given in the question. It's not asked as an answer. It can be doing all sorts of things inside. The name is print, but it can literally solve the shortest path problem using Dijkstra's algorithm. You can do a lot of things, right? But if it returns an integer, it's not going anywhere. Like the output of this is not going anywhere. Like you see how the output of average is going to X, but the output of print is going nowhere. That means whatever output it generates is basically, waste material, right? So usually this is like critical thinking, but you don't need to know, you don't need to go that deep for CSCI 111. If usually there is no cout and it says on the top, right, that this guy is printing this thing, that means the printing happens inside the print because there is no cout outside, right? So it has to be a void. Try to make things simpler because let me think. I get confused in program design question whether the question will be using void or not. Can explain the difference in the design output PDF using two different examples. Okay, we'll go over program design question. Let me see if I can find a void one or a non-void one. Let's see. Okay, I think this one is one of those advanced. Okay, I think I found one void question for program design. Okay, let me see the answer one more time to verify if it's a void or not. 1015, 1015. Yep, it's a void function. Cool. Let's see. Okay, so this is one type of questions you're gonna get asked, which is basically writing a function. So right now they want you to write down the body, including the title line, obviously, of this advanced function. And this type of question usually will have some kind of array component. So you need to know how arrays work and how manipulation works, all that stuff. So let's start writing and advance. So reading the question is basically saying advance that moves each entry one place forward in the array and moves the last entry back to the beginning, blah, blah, blah. So 1, 2, 3, 4, we change to 4, 1, 2, 3. Okay, so basically every value is moving one step to the forward. So 3 becomes the next, 1 becomes the guy. So 31415 becomes 3141 here. And the 5 that was supposed to be here, it was moved back, or moved to the front of the array, right? So x at 0 was 5, x at 1 was 3, x at 2 was 1, this guy was 4, this guy was 1. So combining everything, you get your answer here. So how can you do this, right? So right away, I can see that there is a trick here, because the last part, or this 5 that has to become all the way forward is kind of tricky. But let's not worry about that as of now. Let's just assume everything moves one step forward. So 3 goes here, 1 goes here, 4 goes here, even 5 goes here, even though that spot doesn't even exist. But let's just assume that's the case. So how can we do this? So always when you solve an array equation, there is a for loop or some kind of for loop to go through the array and looking at every value and doing something with the value. And obviously, you guys know how for loop works from midterm 1. So if you do for loop going forward like this direction, I can say, let me write some pseudocode, right? Let's do something here. Pseudocode. So if I write some kind of for loop for int I equals 0, I less than I don't know, 5 in this case, I plus plus. And I know we're basically like moving on, right? So if my current I is at index 0, so my table has 3, 1, 4, 1, 5, this is index 0, 1, 2, 3, 4. The table is called X. So if I say this is my I, the next value is at index I plus 1, right? And the next one is I plus 2, so and so. So basically, if I say something like X at I plus 1 becomes X at I, if I write this line of code, what will be going on is basically taking this value. If I is at index 0, this value is a 3, and I'll put this 3 on this index. So I plus 1 is the next index, so this guy becomes a 3, which is good, looks good because 3 needs to be moved to the next guy. But you see, when I did this, I lost that 1. The 1 is not be found anywhere. Like there was a 1 here, right? I just literally got rid of it. And if I got rid of it, then how do I know that this 1 that I got rid of it needs to be moved to the next one? Like there's no way to even find it because it's gone. And that's why I can't do this one. And what I can think of right now is, instead of going forward direction, what about going backward direction, right? Instead of starting from I here, how about I start I from the back? Like I start from the back. Let me clear everything I did before. This was a 1, right? So if I do this one, and then this value will be I minus 1, right? And I know that this 1 is supposed to move to this box, right? And then 4 is supposed to come to this one spot that was moved before. So I can write some kind of code saying the array at I becomes I minus 1. Let me clear everything out. I becomes I minus 1. If I write this line of code, it will basically take this value, and currently I is here, right? And I minus 1 is basically this guy. And the value at x at I minus 1 is the 1, the 1 here. And I'll take this value and put it in the ith spot. And I know my I is here. This is an I, by the way. So this 1 will be put on to this spot. And you can see that I never got rid of the 1. But obviously, I got rid of the 5. And we can take, so also, remember when I said I don't want to worry about the 5 anymore? I'll take care of it at the end. So let's not focus on the 5 right now. So if I just continue doing this, right? If I go on and then I plus plus, sorry, I minus minus, because we're going backward direction. Next time I will be here and I minus 1 will be here. And I can do the same thing, which is saying x at I minus 1, which is 4. Take this value and put it at this spot. So this 1 becomes a 4. And so far it's looking good because I'm supposed to have 4 at that spot, right? This is supposed to be a 4 and this is supposed to be a 1. That's how I got 4 and 1. And if I continue doing it and then I goes back one more time with the for loop, right? So I will be here and then I minus 1 will be here. Then this 1 will be moved on to this spot. So this 4 becomes a 1. And then 3 will be moved on to this spot. The 1 becomes a 3. And so far it's looking good because 3, 1, 4, 1 is what I'm expecting from the last 4 values. The only problem is we got rid of the 5 originally. And since it's only one value, I can literally take it out before I even start the for loop, saying if I take out the last value, I know the last value is at index length minus 1, and length is given as the second parameter. So I know the last value would be x at whatever the second parameter is called, right? Let's call it length minus 1. If length is 5, 5 minus 1 gives you 4, and 4 is the last index that I'm looking for. And I can literally store this value in a variable called, I don't know, int last value equal to that. So if I store this guy initially before I even start doing anything, then once the for loop ends and once every value is swapped, I can literally at the end, like this, there will be a for loop here, for loop, and the for loop will end somewhere here. And once the for loop ends, once I reach here, then I can put the last value to the first position, right? I can say x at 0 becomes the last value. Because in my approach, every value will be swapped except the last value because, the last value doesn't, last value didn't get swapped with the loop. You can do swap, but there is nothing here. So I cannot put this guy and put it here because there is nothing on this spot whatsoever. And that's my whole idea. Going backward direction and doing this line of code that will automatically move every value one step to the next. And once every value is moved down, I will put this guy at the end, and that will be the end of the function. So if I start writing the code, actually, it's called advance. So advance, and it takes 2 parameters, right? First parameter is x, and x is a type integer array. So I will say int x. Also notice that the sign of the array is after the variable name, but when you declare it, where is it? Never mind. Not sure what I'm talking about. Don't worry about it. So the first parameter is type integer array, and then second parameter is the value 5, right? 5 is a literal integer, and I know this value is almost always the size of the array. So I can call it length. You can call it whatever. You can call it size. You can call it A. You can call it B. You can call it C. Whatever, right? It doesn't really matter. I'm gonna call it length. And what's the return type? Again, what is this function is doing? Actually, let's not worry about the return type as of now. Let's just finish the code first because we're gonna forget that if we don't do this. And then at the end, we will figure out the return type here. So what I said is that there'll be a for loop component, and the for loop is supposed to iterate backwards, right? Basically saying, I want to start from this guy, and then I'm gonna go this direction. So how do I know what is this value? This value is my length minus 1, right? If length was 5 here, and the last value is 5 minus 1, which is 4. So I can start my for loop saying int I equal to length minus 1 because that's the last value. And I will be iterating backwards. So it's not going to be I plus plus, it's going to be I minus minus. And
you
go ahead.
You need to set it as I is greater than or equal to 0.
Almost correct.
Because you're decrementing.
Yeah, you're right. Almost correct. Only problem, so let's just keep it I greater than equal to 0, and then we'll see what the problem is. So what I said is I'm gonna write down literally this line of code, because this line of code basically moves every value to the next value. So I will say x at I equal to x at I minus 1. Basically taking the previous value, this is the previous value, right? Taking the previous value and putting it in the current position, right? So now if I keep it as it is, there's gonna be a problem here. The problem is so this loop will go from I equal to 4 originally, because 5 minus 1 is 4. Then it will go to I equal to 3, I equal to 2, I
It's
equal
gonna
to
go out
1.
of bounds
Exactly, I equal to
because
0. When it becomes 0, what is I minus 1 that I did here?
-1, which will be out of bounds.
Exactly. So it can never reach 0. You can never come here. The latest you can go here is this position.
So then
So
you
it's not
could
gonna be
just
less.
change the greater than or equal to just greater than.
Yeah, you can do this, or you can also do greater than equal to 1. Both of them are correct. I like to do this way, so I know where it exactly stops, right? It literally is it's gonna stop as at 1. But also what Akrab said, you can do greater than 0. That is also correct. So again, this line of code will literally take the previous value and put it in the current value, and that will do everything except we didn't store the last value. So let me store it before everything. So int last value, which will be x at length minus 1, because array is at 0 index. If length is 5, my last value is index 4. So 5 minus 1 is 4. And after the for loop ends, like this is where the for loop ends, this is where I can say my first value, or x at 0, is going to be the last value.
I have a
Technically
question.
speaking, you can put it here as well, I'm pretty sure, because no, you can't, because you need the first value. Yeah, someone had a question. Yeah, go ahead.
Okay, can you quickly scroll back up? I
Yep.
just want to understand. So you're taking the length of the array minus 1, the position, which will be the length of which is going to be 4. You'll be taking 5, and then you'll set that equivalent to x of I minus 1. So you're essentially taking position 3, place it as position 4, and as you continue to decrement, position 3 will then have the value of position 2, and then you continue to decrement, and then position 2 will have the position 1, and then position 1 will have position 0. So doesn't that kind of solve itself?
Yeah, but so did we ever change position 0? We
Oh
took the
no,
value of
right.
0.
Okay,
Yeah, so that's why the last value makes sense.
that makes okay. Yeah.
Yeah, I can go with the random number question right now, right after this, because we have like a lot of time. Hanan, I think, if I didn't butcher your name. Yeah, so that's gonna be the entire code. And now again, what's the output of so what's the return type of this code, or return type of this function, right? It's gonna be void. Reason because, let me clear everything out first. Mm, So if you look at this function, right, it's calling this function, advanced function we just made here, right? And then we're not, see, there's no comment here, like what the function does or anything like that. What the function does is written in the equation actually, but it doesn't say anything. If you look at the question, I'm pretty sure there is no word return here. Let me read it one more time. Function blah 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 blah. Yeah, you see that in the description there is no mention of what it's returning. So in those scenarios, it's almost always a void function, because it doesn't even say what you should be returning. So you should return nothing. And how do you return nothing is with a void function. And the other trick is looking at the code. and I see that there is no comment first of all, and what the function does, like what the return type of this is stored at nowhere, like there's nothing here actually. So the output of this function is nowhere it's going, and inside the function we change the values, right? We change the values such that when we printed the cout, I had the changed values here. So everything that happens in the advanced function is happening inside the advanced function. So there is nothing is returning from that, or nothing is outputting from that. So that's why the return type has to be a void. Yeah, so again, that's how you write the function, whatever program design questions. This one will not have any kind of recursion involved. It's basically knowing or manipulating an array, I should say. And you need to know how to iterate, like you need to know when to go forwards, when to go backwards. Well, someone asked, why can't we do I equal to I plus 1? Yeah, so the reason, I think I explained it, but let me do it one more time. So if I did something like, okay, if I did something like x at, what did you say one more time? I equal to I plus 1, I equal to x at I plus 1. If I write this line of code instead of that line, let's try to find out what will actually happen. So let me write down, let's put a comment here. So this is saying take the next value and put it in the current value. So if my array had 3, 1, 4, 1, 5, this line of code will take the next value and put it in the current value. So this whole thing will become 5, 1, 4, 1, and then this guy will wrap around and go here, this guy. And this is not the output they're looking for, right? If you look at the output, it's actually the other way around. So we're not going this direction, we're actually going that direction. And that's why
Wait, doesn't that cause an error though?
yeah, obviously it will cause an error because it's index out of bound for some cases. But Tasnim asked me why we can't do that. So that's the
Like,
reason why.
I have a question. Like, if I use in the for loop instead of int I equals to length minus 1, but use like int I equals to 0, like,
Oh yeah. So in that case,
then,
if we are going forwards,
yep.
so let me see. So if I start from this guy and I do I equal to I plus 1, again, what it will do basically, I plus 1 is this guy, right? It will take this value, put it into this value. Actually, you might be right. Why can't I do that actually? You can, I think you can also do this as well. Let me think. So if I do I equal to I plus 1, it will take this value, put it here, which is fine. Is it fine? No, it should go next one. Oh yeah. So it can't do that because this one is supposed to go here. It's not supposed to come back here because this line of code is taking the next value. So this is I plus 1. This line of code is saying take the I plus 1 value and put it backwards. But we don't want that. We want it forwards, right? If you look at the answer, the first one was in the second position, but it was moved to this third position.
Yep.
Okay, cool. So that's how you do it. Someone asked, can I do the random number question? Let me just quickly do this before I move on to recursion and anything else if you guys have any question with. Let me think. I'm pretty sure I saw a random number question somewhere in the thing. So, okay, found it. 1, 0, 1, 1. So this one uses random number. I think Hanan asked to do this. So Basically, okay, I see. So what the question is saying is for every number in the array, it's the same array actually, I just realized it. So we have 3, 1, 4, 1, 5. And every value, we're gonna add any number between -2 to +2. So we can add -2, -1, 0, 1, or 2, and I have to find a random number between any one of the 5 and add that value to 3. So if I do 3 minus 2, this becomes -1. Sorry. 3 minus 2 becomes +1. 3 minus 1 becomes +2. 3 plus 0 becomes 3. 3 plus 1 becomes 4. The hell? Yeah, and then 3 plus 2 becomes 5. So once I run the function, this value will be changed to any one of those. I don't really know which one it is, but the one they actually did was the second value, so that's why the numbers didn't match, because second value was actually 1. So if I do 1 and any one of the 5, you're gonna get any one of these 5. And basically they're asking to find random number from this list and add that value to each one of the array items. So let me quickly do this first, and then I'll move on to recursion. So this function is called adjust. Adjust. I will keep the return type empty for now. If you can guess, you can let me know. And sticking 2 parameters again, same as before. So x, and I'll call it length one more time. And there will be a for loop. Again, there is this is an array, so there will be some kind of for loop component that goes forward. For int I equals 0, I less than length, I plus plus. Again, this part you can say less than equal to length -1. That also works, right? And then I'm gonna do for every value. So for every I, let me write it here, x at I will last equal some kind of random value, right? This is the random value that I need to figure out, right? So let me write the random value here. Int random value, and this value will be the taking 1 out of this 5, right? So how can we do this? So there is a rand function, I'm pretty sure that C++ gives you, and this function, let me think. So if it was right minus left plus 1 plus L and mod. Okay, so basically what I did here is think of your list as like a I don't know, if it's incremental. What I mean by that is, like, if there's no number missing, right? From -2 to +2, there's no number missing. We have -2, -1, 0, 1, and 2. And for 111, there will not be any number missing. If they ask you to find a random number, it will find a random number between, I don't know, 100 and 900, something like that. Or in this case, which is -2 to +2, right? In those cases, the rule is this: find the range. If I have -2, -1, 0, 1, and 2, how many values are there? The values, there are 5 values, right? And that's my range, or that's the amount of value I'm picking from, right? The amount of choices I have, I should say. And that range is basically this equation. This looks complicated, but for now, you don't need to know all that. And this L is the offset. What I mean by offset is, where does the range start from? Not always the range start from a 1. Not always the range start from a 0. In this case, the range start from -2. So this value is -2. It's always the range or the amount of options I have plus where does the range start from. So if I do, and there's a modulus operation before, right? If I do this question, it will be rand and then modulus, and then my range is 5, right? Actually, no, it's not like that. It's not like that. It's basically, you have to use the formula, actually. You have to use the formula. I cannot just find the value 5 here. I think you have to use the formula. So what R means is basically the right side of the range, which is this value. What L means is the left side of the range, which is this value. And, this is whatever that is. If I use the formula, it's going to be R minus L plus 1. So my R is positive 2 because the right side of the range is positive 2. And then the left side of the range is negative 2. So let me write negative 2 here. And plus 1. And then plus the offset. So where does the range start from? Negative 2. And I think I have to put in a one more parenthesis so it wraps the whole thing with the modulus. If you don't add the the extra parenthesis, I'm pretty sure it will be calculating this part first and then add -2, which is not correct. Let me actually look at the answer sheet to figure out if I'm right or wrong. 1001. Not sure they did modulo 5. Okay, so you can actually do that. I was not wrong originally. So you can actually do 5 here. Like, instead of having this entire complicated stuff, you can actually have 5 here, which is basically the number of values, the range of options. Or if you want to memorize this equation, that's also fine, whatever makes more sense to you. And that's exactly it. And this will generate a random number between this range, right? This range. And once I find the random number, which is stored in this value, I'll be adding that value to my every item of the array. And that's exactly what the code needs to do. There's nothing else involved. So my entire function is this, and the only part I'm missing is the return type. And you should be able to figure out what the return type for this function should be, which is void.
I have a question.
Yeah, go ahead.
Do we have to use the time function because every time we run the random, it gives us the same value. So
Yeah,
for
good
us
question.
to
So
keep changing the random value, so we have to use the time function, right?
yeah, good question. So basically, the time function is used in the main function originally. So when you write a random function, you do srand time here. But since this question doesn't have the time here, you should do that time inside the
Function.
inside that. Yeah, exactly. I think it's called seed random, or in short, they call it srand, and you do time 0, which is basically saying the current time. It's basically saying take a random number, take a seed a random number, in short srand, and time 0 is the current time of whenever you run the program at program 2. So this one will give you a true random value every time, not just one random value and then take the same random value every time. So you need to do this. You need to do this line because this line is not given in the main function. But
It's
yeah, that's
mandatory to place it, correct?
yes.
I'm sorry to say. Another thing is like I checked with my lab professor, so she mentioned that we don't have to simplify, this random generation. So just use maximum minus minimum because that is what computer is supposed to do. We don't have to simplify, the result for computer to do it.
Yeah, exactly. Both of them are correct actually. You can actually simplify it. You can say the answer sheet actually says 5 here. Like this whole thing, the answer sheet has a 5 here. But both of them works. If you don't simplify it, the computer will simplify it for you. But I think it's better to know the formula, which is maximum is the R, minimum is the L, maximum minus minimum plus 1, which is the number of items here, or the range of items, plus where does the range start from. And I guess it's not very difficult to memorize it. If you want to do that, that's fine. And both of them works basically. That's the answer I'm looking for. So whoever asked for this question, does it make sense? If it does, then I'll move on to the next topic, which is recursion.
I have a question actually.
Yeah, go ahead.
Like in this problem, there was a line like the biggest allowed change to an entry of the array is either up or down, and the smallest allowed change is 0. I did not get that line.
Mm. Oh, okay, this line. The biggest allowed carry changed an entry there. Oh, basically this is saying in general, if you took like some kind of math course that teaches absolute value, it's saying the biggest allowed of change, like what is so when we add this kind of stuff, what's gonna happen? -2 will decrease the value by 2, -1 will decrease the value by 1, 0 will keep it same, 1 will increase the value by 1, 2 will increase the value by 2. So basically we're changing by either 2 or 1 or 0. Now negative goes in the other direction, positive goes in the other direction. So they're saying the biggest allowed change you can only have 2. So it's the same idea. I mean, there's nothing complicated about that line. And the
Why'd
smallest
you
yeah.
explain the logic behind the random mod 2 minus -2 plus 1?
Okay, so this part again, this is the range portion or the amount of what are you saying why we are modding it?
Yeah.
So I'm not sure if you're familiar with modulus. So if you mod a number, it can be any number, right? I don't really care. It can be 1,300,500,000,000, whatever, right? If you mod 7, the result will only be 0, 1, 2, 3, 4, 5, or 6. It will be
So
any one of those.
so you're creating a simulated absolute value.
Exactly. And if you do mod 5, the result will only be from 0 to 4. It will basically stay in this range. So that's why I add where does the range start and how many values do we have, which is the range of the thing. And I basically mod it so it stays between, in our case, which is -2 and +2. So it stays in this range.
So where did you get the R and L for this case?
R is the maximum value. Maximum value is 2. And L is the minimum value, which is -2.
-2.
And yeah.
I see. Gotcha. And why did you increment by 1, if you don't mind me asking?
Well, that's if you don't do it, then your range is 1 off. So how many values are there? 5, right?
Right.
If I do 2 minus -2, what's that? 2
It's gonna be
plus 2,
4.
which is 4, which is 1 off, right? So I have to do +1. So 4 plus 1 gives you 5.
5 minus 2 is just gonna be 3 then.
Yeah. Okay. So let's do one.
So you're taking a random number mod 3?
Basically, yes. Yeah.
So why add that equation when you could just do that if you know the
Well,
value?
you can you can actually figure it out. Let me see the answer question. It says 5 minus 2, I'm pretty sure. Oh no, you can't do that. Well, what you can do actually, you can do something like this. Oh, I was also wrong. You should not add these parentheses. The reason behind that is the parenthesis is actually here, not there. Let me separate stuff so you will see what's going on. This is what random number is generating. This part equates to 3, right?
Right.
So that means random number is getting a value modulo 3. So it can only be 0, 1, or 2 just from this part.
Wait, but it's 4 plus 1, so it's 5. The range is 5.
Oh, sorry, my bad. Yeah, 5. So 1, 0, 1, 2, 3, 4, this part. And then we're adding the offset so that it never becomes 3 or 4. Every number will be -2. So this guy becomes -2. This guy becomes -1. This guy becomes 0. This guy becomes +1. This guy becomes +2, which is exactly what the question is asking for.
Okay. But
So
what about the final element where it's 3?
what do you mean? This 3?
So it says that it could print any value between -1 to 3.
Oh no, that is because this part is because the x at 1 was the value of what was x at 1? 1, right?
Right.
So if I add 1 plus 2, sorry,
It's gonna be 3.
3, and that's what this value means. And 2 is basically 1 plus 1. And then 1 is 1 plus 0. And then we have 1 plus -1,
0.
which is 0, and then the other one is -1. So these values are coming from x at 1, not just, the whatever that is.
I see.
Cool. So let me see if I missed anything from the chat. Can explain why is not void. I think we did. Give you confession, blah, blah, blah. Yep, we're all good. So the last topic will be recursion. Let me find a recursion question from the problem set. Or if you guys want me to go over one of the recursions, so you could tell me. For x1, why do we add 1? What do you mean by why do we add 1? We are adding any numbers between this range, right? -2, -1, 0, 1, and 2, because it's said here. So whatever value x at 1 has, which currently initially has 1, right? I'm gonna try to add any number between this range, and the positive 1 do include, like, it's inside that range, right? So that's why it can print any number between any one of those. It's not the entire array, by the way. These are like options for just this item. It just prints a value that could be any number of that. This is not the entire array. The entire array will be anything different. These are the basic options that you can get from x at 1, because x at 1, if you add any one of 5, you will get any one of these 5. Does that answer your question, Jainab? Okay, cool. So let me go to recursion quickly. Let me see. Recursion. 3, 1. Okay, we can do question number 4, which is 1016. I think I've seen this question before, actually. Okay. So this is the question from the one of the questions from the problem set. It's basically writing a recursive function, which is called digit opposite. And wait, what's going on here? Two integers parameter x and y that are positive and have the same number of digits. It returns the number of positions where one number is an even digit, other one is an odd one. So basically saying, okay, so couple things to notice. If the question says it will have same number of digits, that means if one of them has 5-digit long, other one will be 5-digit long. You're not gonna have 5-digit and 4-digit, or 5-digit or 3-digit. So that's something. And then basically we're counting where the parity changes. What I mean by parity is the odd or even, right? If the first number is odd here, I'm expecting the second number to be odd. Okay, we're good. If my first number is, second number is odd here, I'm expecting second number to be odd. We're good. Third number is odd here, but now third number here is even. So now there is a mismatch. So far, I see one mismatch. Now fourth number is even here. Fourth number is odd here. So now I see two mismatch. Fifth number is odd here. Fifth number is odd here. So that's all good. And that's why that is my result. Now on the next one, it prints 5 because all 5 of them has different parity. First one is odd, this one is even, this one is odd, this one is even. You'll get the idea. So that's what we're trying to figure out. How many positions does the parity change? Or the odd, one of them is odd, other one is even. And they want to write a recursive function, so you can't do it non-recursive way. So let's start writing digits opposite. Usually for recursion or recursive questions, it's almost always two integers, integers, or one integer, or maybe 3 integers. And how recursion works in general is basically you originally call with a larger input, and you kind of break it down into smaller inputs. So originally we are calling with a digit with 5-digit long, or number with 5-digit long. Next time we wanna cut one of them out, and then my answer or my input will be 4-digit long. Next time I will cut one of them out, so my answer becomes 3-digit long. And then I'll cut one more out, then becomes 2-digit long, and one more out becomes 1-digit long, one more out then becomes 0. And that's the whole idea. You wanna have a larger number and you want to cut one at a time so that it eventually becomes or goes toward one of the base cases. And what is the base case? You can generate it whatever the question requires you to write. So let's quickly write down the parameters. I'm going to call it, I don't know, A or B. You can call it X or Y, whatever makes more sense to. And what is the output? Let me think. So right now it says there is C out, right? Remember when we mentioned before? If I have a C out, it can't be void because if it was a void, it will not print out anything. But it is saying it prints something. It prints the number, right? That means whatever is outputting or resulting from this function has to be this number, such that this number is printed because we are counting it. That's why it has to be an integer. Okay. Again, if there was no cout here, if it was not there, then you could write void here and it would have been fine. But yeah. So now, what's the idea? The idea is, you can, okay, let me think. So let me ask you this. What is easier to access? Is it easier to access this number and this number? Or is it easier to access this number and that number? You guys know how modulus work, right?
Yes.
Exactly, yeah. If you guys know how modulo work, it's modulo 10 always give you the last number. And since we can access the last number easier, so that means that next time I should get rid of the last number, and then my number becomes 1734, and then I get rid of the 4, and then it becomes 173, so and so. So now I will compare the last number or initially check this guy with this guy. If the parity change, I will do something. If the parity doesn't change, I'll do something else. So how can we do this? Let me see. Whoops, sorry. So let me write in the recursive calls first. Actually, let me write in the last number. So int last of A, which will be A mod 10, and int last of B will be B mod 10. So we're basically getting, this one is 5, and this one is 3. So now we have to check does the parity is the same. In other words, I'll need to check if last of A, you know how to get the parity, right? Or if it's even or odd, it's always mod 2, because mod 2 gives you 0 or 1. 0 is even, 1 is my odd. So if I do mod 2, this will be even or odd. You can do it in one line, which is saying if this one is equal to the other one, which is saying last of B mod 2. You can do something like this, or if it looks complicated, you can do it separately. That's also fine, which is saying if last of A mod 2 equal 0 and last of A mod 2 equal 0, that means both of them are even, right? Then I can copy the same thing and then say, I'm sorry. This is 1, this is 1. So these are both odd. They should be B actually. Why am I saying A both times? So first one is saying both are even, second one is saying both are odd. So the other only case where they're, interchanged, which is else case. So else basically meaning one of them is even, other one is not even, or one of them is odd, other one is not odd. So you can do it like this, or you can literally do it one line, which is saying, are they equal? If this one outputs 0, this one should be 0. If this one outputs 1, this one should be 1. So I'll do it in one line, so we're not, sorry. But I can keep it here if you guys want to experiment or whatnot. So if it's even, we said that if we have the same parity, we don't change anything, meaning we don't change the result, right? Or the whatever the count. If we had same parity, we did not add anything. So that means I will return the result of same function name, so digit opposite, but I will pass in smaller values. And how do I pass in smaller values? It's always divide by 10. And divide by 10 gets rid of the last number. So if I have 1, 1, 7, 3, 4, 5, and I divide by 10, this result is going to be 1, 7, 3, 4, which is basically getting rid of the last number because we already calculated if the last number has a different parity or not. So almost always on recursion is knowing when to use modulus and when to use division. So now we do A mod 10, so I have to do B mod 10 as well. Not mod, I'm sorry, B divided by 10. And that should do it. Else, which is when the parity is not the same. One of them is 0, other one is 1, vice versa. I will do this guy, same guy, right? But I will do +1. That means this +1 is saying for the last digit or the digit we just calculated has a different parity. But this one was same, so we didn't do anything. You can write +0, but it's the same thing. We don't change anything if they're equal. If they're not equal, which is the else condition, or you can also write this thing. Except this should be not equals. This is also fine. If they're equal, we don't add anything, we add a 0. If they're not equal, we add a 1. Because my current digit has a different parity. And that's my entire code actually, except we're just missing the base case. So we need to find out where does the recursion stops. So this is fine. Again, these are comments, so we're not doing else and then if. We're only doing one or the other. I'm just keeping it because both of them works. So my base case will be, so what if initially when I call in the main function, they're 1 digit long, digit blah, 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 blah. I call it, I don't know, 1 and then 2. Result should be 1, right? Because they are different parity. So in that case, last of A will be 1, last of B will be 2, because 1 mod 10 is 1, 2 mod 10 is 2. And then I'll check this line of code, which is saying, if they're same or not. They are definitely not the same. 1, this is 1 mod 2, this is 2 mod 2. This guy will give you 1, this guy will give you 0. 1 is not equal to 0, so we're not gonna do this line. We're gonna do this line, and this line is saying A divide 10, B divide 10. What is my A? A is my 1, right? And B is my 2. So it's like saying 1 divide 10, 2 divide 10. What is 1 divide 10? In math, we know it's 0.1, but in comp sci, it's integer division, so it's going to be 0. Same thing with 2 by 10, it's going to be 0.2, but integer division makes it 0. What I'm trying to ask you is, any number, if you divide long enough, it will eventually reach 0, both of them. And that's my base case. No matter how long the number is, if it's 5 digit long, if it's 10 digit long, if it's 100 digits long, once I divide by 10 long enough, it will eventually reach 0. And that's my base case. That's where I stop the recursion. So if A equals 0, again, the question said they will have same, where does it say? Same number of digits. So if one of them is 0, other one will also be 0, because we will have same number of digits. You can do or B equals 0. You can do and B equals 0. You cannot even do anything with it. All 3 options are fine, because they're gonna reach 0 at the same time. Only when they have different number of digits, that's where one of them will reach 0 earlier than the other. So one of them had less number of digits. For now, we are given that same number of digits. We're gonna assume that if one of them is 0, both of them are 0. So in that case, I can return 0 because 0 and 0, if you think about it, if A is 0 and B is 0, they're the same parity, right? Like they are both even if zeros count as an even. And this my entire code. Let me clear things up so you guys can see it.
My question to you is, do we have to write the base case first or do we have to write the recursive case first?
So when you answer it, it doesn't matter. You see, when I answered it, I write down this part first, which is the recursive case. This is the part we recurse. And then at the end, I just added this line of code in the beginning. But if you write the code, this line of code has to go before this line of code. Like base case has to be the first thing you do on the code, right? Like if I do this line of code at the end, this is no good. This is not gonna work out. So this has to go before. But when you answer it, if you wanna answer the base case first before the recursion, that's fine. If you wanna do the recursive case first before the base case, that's also fine. So basically whatever makes more sense to you. I'm not sure what is this actually.
Actually, I have a question.
Yeah, go ahead.
What if we have only one digit for both of them?
Yeah, that's
Like
exactly what I did.
only,
So in that
like for
case,
example, only one. A, like A is 1 and B is 2.
okay, fair enough. So is A equal to 0? It's not. What is last of A? Last of A is 1 mod 10, which is 0, right? And 2 mod 10 is also 0 because, well, no, it's 1 and 2. What am I doing? Mod 10 is the last digit, so it's basically 1 and this is 2. Yeah, so mod 10 always gives you the last digit, so it's 1 digit long. So last of A is 1, last of B is 2. So in that case, are they equal? So 1 mod 2 and 2 mod 2, are they equal? This one is 1, this one is 0. So 1 is not equal to 0. So we don't do this portion, we do this portion because right now they are not equal. So we'll call recursion one more time and I'll pass in 1 by 10, 2 by 10. 1 by 10, if you do a calculation, is 0. 2 by 10 is also 0. So in the next time we call the same function, my A is 0, B is 0, and now this line passes, right? So we're not gonna do any more garbage when they're both 0. So this line passes, so we're gonna return 0. That means when we did this part, like this part had the value 0. So we're gonna return 0 plus 1 because there's a plus 1 here. And that's my answer for when A was 1 and B was 2, which is right because there's different parity, so it should be 1.
Thank you.
Okay, so this is like one of the example of regression. Again, you need to find out how to recurse or how to call the same function with smaller inputs. And for 111, it's almost always some kind of integer. And if you divide the integer by 10, you get rid of the last digit, so it becomes smaller. So almost always you're gonna have some kind of some type of this kind of recursion. And this 0 or 1 is basically depending on the question. The question wanted me to add 1 when they're different parity, so I added 1. And when the same parity, I don't do anything. So this doesn't even matter if you like it or not. Any questions so far? If not, then I will do question number 122 as someone requested. This is the program architect question, the one we did initially. But if you want to leave, that's completely fine. But before you do, please fill out the feedback form. It helps us in many ways. We keep track of it to host more events in future. Is it the one you wanted me to go over, Tasnim?
Yes.
Okay, so we're gonna go over this right now. Okay, so I'm gonna tell you this. I haven't seen while loops and whatever that is in the second midterm. These type of questions, the while loops and looking at outputs are part of the first midterm. So you should not focus on this. You should focus more on where was it? Like this kind of stuff, having arrays, having functions and modulos and all that stuff. You're gonna more likely get this kind of stuff than this one, because this is part of exam one or midterm one topics, but I can go over it if you guys want. So basically, let's just go line by line, right? First, initially, I do I equal to 1, j equal to 1, k equal to 1, and then, yeah, go ahead. Wait, I'm sorry, you're cutting out. I'm not sure if you said something because I did not hear it.
Sorry.
Okay, so now we do the while loop, and what while loop does is, as long as I is less than 10, which currently is because 1 is less than 10, we're gonna do I plus plus, right? I plus plus basically updates by 1, right? So first time is gonna be 2, and then we're gonna check if 2 less than 10, it's gonna update to 3, is 3 less than 10, it is updated to 4, so and so. It's gonna become all the way up to 10, and when it becomes 10, 10 is not less than 10. That's where the while loop ends. So then we go to the next line. So when I do cout, I'm basically couting. So I'm gonna do the console here. I had initially I plus plus. So initially I had 1 plus 1, which is 2. It was 1 originally, but I plus plus becomes, well, no, it will be 1 because it's post increment, not pre-increment. So I print 1 first, and then I update the value to 2. Similarly, it's going to be 2, 3, 4. Well, it's going to be on the same line because there's no ENDL. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Give me a second. 9, and then when it becomes 10, I would not print 10 because once it becomes 10, the while loop fails, right? This guy fails. So we never printed 10 and made it 11. This is what is going to be printed just from this line of code. And then I do ENDL. So now I am going from here to here. And then I'll move on. Again, J does the same thing, except we do pre-increment. And pre-increment meaning we update the value first and then we print. So originally J was 1. So we update the value first, becomes 2, and then I print that value to the screen. Opposite, right? Because we pre-incremented. Same thing, and then we become 3, 4, 5, 6, 7, 8, 9. Now, when it was 9, right? I did while j less than 10, while 9 less than 10, which is true, right? Which is correct. So we're gonna go inside, and I'm gonna do cout plus plus j. Plus plus j changes the 9 to a 10, and then I print that value because it's cout. So I'm gonna print out 10, and then I do the same while loop. Now it's 10 less than 10. Now this is not true. So we're not gonna print anything, we're gonna end it. And then I will move on to the next line. So basically pre-incrementing and post-incrementing, that's what all the question is asking here. Post-incrementing is print it first and then update the value. Pre-incrementing is print last, but update first. And then I will do cout ENDL. So the cursor goes from here to here. And then the final part is the while loop, which is saying plus plus k less than 10. Okay, so what is k value right now? K is 1, right? So I do plus plus k first because it's pre-increment. So k becomes 2 now. And then I check is 2 less than 10. It is true. So I go to Cout and then I print the value first because it's post increment. So I print the value first and then update plus plus. So it becomes 3 here. The next time I do the while loop condition, it does plus plus k. So plus plus k means update the value first and then check. So I updated it to 4 and then checking is 4 less than 10, which is true. So we go to the Cout statement. Cout statement printing the value k first. So k right now has 4. And then update the value of k. So k becomes 5. Do the same thing one more time. It's gonna be plus plus k, so becomes 6, and then checking is 6 less than 10, which is true. Go to Cout, print the value 6, and then move on. So you can kind of see the pattern, right? It becomes 2, 4, 6, 8, 10, blah, blah, blah. So next time it's gonna be sorry, give me a second. So we had 7 here, and then do the while loop condition one more time. It does plus plus k, so plus plus k meaning change it to 8, and then 8 less than 10, which is true. So go to Cout. Cout prints the 8 first, and then update the value of 8 to a 9. And then we do the same thing one more time, plus plus k is saying make 9 to a 10, and then check is 10 less than 10, which is not true. Not gonna do any more printing. Go to the next line, and that's my end of the console. So that's what you're gonna see in the console.
Thank you.
Okay. Yeah. So again, you're not gonna see this set of questions, I'm pretty sure, on midterm 2. You're gonna see questions that involve function, arrays, blah blah blah. So don't focus more on that. Yeah, that's the end of the revision, I believe. Again, before you leave, please do the feedback form. We keep track of that to do more revisions in future. Also, it's recorded, right? Yeah, it's recorded. So we're gonna post the recording in the Learning Commons YouTube channel and the website. And I'm pretty sure you'll get some kind of notification from Professor Akinlar once it's posted online. Okay. So yeah, that's the revision. If you guys don't have any questions, feel free to leave, and I'll stay for 1 or 2 minutes, and then I'll close out the session.
Thank you so much. It is really insightful.
No problem. Have a good night.
You too.